Hello everyone, good afternoon all the students. Welcome to Toppr JEE, your one-stop solution for all your JEE preparations. So guys, good afternoon everyone. So today we are going to discuss another topic of differential equations, and that is going to be variable separable method to ho gaya in the previous class. Okay, so in today's class we are going to discuss about the homogeneous equation method and the linear differential equations. Okay, so the two topics which we are going to discuss in a very detailed way in today's session. So guys, let me wait for another few minutes. I guess the students are joining. So good afternoon everyone, good afternoon guys, good afternoon. So let us begin the session then. Everyone excited of today's session. So if you see in the previous class we have discussed the basics of differential equation, guys. And also we have discussed about the concept of which one? The concept of variable separable method. Okay, if you have missed out the previous lecture, guys, you can find that in the playlist. You can find the playlist in the description. Okay, in the description, you go to the description, वहाँ पे आपको playlist मिल जाएगा. Okay, of all the classes which we are done, which we have taken till this particular point. Okay, so chalo guys, let us begin the session today. So this topic is a very important topic, guys, especially linear differential equation method. If you see the previous year question, guys, you can find from this chapter 50 to 60% of the questions are based upon the concept of linear differential equation only. So you can understand the importance of this chapter by that. Okay, so with that, everyone, यहाँ पे let us begin the session today, guys. So first important thing for you is that let me give you a very short intro about myself. I know most of you might already be knowing me, but let me give you a very short intro about myself, guys. This is Goutham. I've done my graduation from NIT Surat. I've been teaching from past 4 years and have taught almost 10,000 students online and offline. Okay, so that was a very short intro about myself. So chalo guys, let us begin the session today. Okay, hello guys, hello everyone. So good afternoon students. So let us begin this session today. So the first concept which we are going to discuss today is going to be the homogeneous function. So first we'll talk about the homogeneous differential equation method. So for homogeneous differential equation method, to understand the homogeneous differential equation method, it's important for you to understand what is a homogeneous function going to be. Okay, so let us first understand that in a detailed way. So guys, if you look at here, if f of x comma y is a homogeneous function, then it is going to satisfy this particular equation, everyone. So for example, you take this equation. Okay, let me take f of x is equal to x square plus x into y plus y square. Okay, now in place of x and y, let me take this equation as f of x comma y. Okay, so let me take f of x comma y, and that is equal to x square plus x into y plus y square, everyone. If you replace x by lambda x and y by lambda y, you see what am I going to get in this case, everyone? So in place of x, lambda x, in place of y, lambda y. If you take lambda x and lambda y, you end up getting lambda square x square plus lambda square into x into y plus lambda square y square, which can also be written as lambda square into x square plus x into y plus y square. Or we can also write this as lambda square into f of x comma y. You see, I'm basically getting this condition that f of lambda x comma lambda y is simply going to be equivalent to lambda square of f of x comma y, everyone. I'm getting this condition. So what does this basically mean, everyone? What does this basically mean? Well, this simply means that this equation which we have taken, f of x comma y is equal to x square plus xy plus y square, this equation is simply nothing but a homogeneous equation. We can say it is going to be a homogeneous equation, everyone. So I hope it's clear for you that definition of homogeneous equation, which is going to satisfy any equation which is going to be a homogeneous equation, which is going to satisfy this condition. Any homogeneous equation is going to satisfy this condition, everyone. Okay, now there are certain examples given for you. For example, you see 5x cube plus 6 into x square y minus 5 into y cube. This is going to be a homogeneous equation, right? If you replace x by lambda x, y by lambda y, you end up getting this criteria, man. F of lambda x comma lambda y, this is going to become lambda cube into f of x comma y. You are going to get this condition, right, everyone? Can we say यहाँ पे this is what you're going to get, f of lambda x comma lambda y के लिए you're going to get lambda cube into f of x comma y. So this is the condition you're going to get for this equation. So what does that mean? Well, this equation is also going to be a homogeneous equation. Okay, now can you tell me, will this equation be an homogeneous equation, everyone? Is f of x comma y equal to x cube by y square? Is it going to be a homogeneous equation? Well, how would you know that? How will you understand that? Very, very simple. Guys, आप लोग यहाँ पे क्या करेंगे? Again, replace x by lambda x, y by lambda y. You see, what am I going to get in this case? Well, you are going to get lambda cube, x cube divided by, okay, and what is this one going to be? Lambda square, and it's going to be into y square. Okay, now can you tell me यहाँ पे आपको क्या मिलेगा? Lambda square, and यहाँ पे this is going to be cancelling out. So I'm going to get lambda into, okay, I'm going to get x cube divided by y square. So you can clearly understand that I'm getting f of lambda x comma lambda y to be equal to, okay, यहाँ पे you're going to get lambda into x cube divided by lambda divided by y square. So this is what you are going to get, right? Lambda into x cube divided by y square. This is what you are going to get, right? So now you tell me, if you're getting this type of equation, is this going to be a homogeneous equation, everyone? Will this equation be a homogeneous equation? Guys, this is a simple task for you. Let me know in the comment section if f of lambda x comma lambda y, which is going to be lambda into x cube by y square, will this be a homogeneous equation? Guys, let me see who is going to give me the answer in the comment section. Do let me know this answer in the comment section, everyone. Okay, so chalo. Now let me start discussing about the concept of homogeneous differential equation. Okay, now you see here, everyone, if I have an equation in this way, let us say a differential equation of this particular type. Now everyone try to understand, if you can write the differential equation in terms of, in a general way, in this particular way, we can say that differential equation is going to be a homogeneous differential equation, everyone. So for example, let us say you have dy by dx is equal to, okay, let us say x plus y divided by x minus y, everyone. Okay, let me take an example of this one. Dy by dx equal to x plus y divided by x minus y. Now guys, try to understand if this is going to be a homogeneous differential equation or not. How do you check that? Well, I already have given you this simple form that any differential equation, if a differential equation is given for you in this particular way, dy by dx is equal to f of x comma y divided by g of x comma y. If you can write this right hand side as a function in terms of y by x, let us say you're writing f of x comma y divided by g of x comma y as h of y by x, that is in terms of y by x, everyone. Okay, then we can definitely say that this function dy by dx is going to be dy by dx equal to h of y by x. Guys, this is definitely going to be a homogeneous differential equation, everyone. So see the question, everyone, यहाँ पे dy by dx is given x plus y divided by x minus y. So in this case, I can do the simplification in this way, right? I can write down dy by dx is equal to, if you take x as a common, I'll get 1 plus y by x divided by 1 minus y by x, everyone. Okay, now from here, everyone listen to this carefully. यहाँ पे देख सकते हैं आप clearly कि you see the function on the right hand side is simply nothing but in terms of y by x. So can we say this is going to be a homogeneous differential equation? Yes, definitely. So this is going to be dy by dx equal to x plus y by x minus y. This is definitely going to be a homogeneous differential equation. Okay, now the question. So how should we solve this equations, everyone? How are we going to solve this homogeneous differential equation? Now let us learn a method for that. We have a method for solving the homogeneous differential equation. So everyone listen to this. Hello Raj. Good afternoon Raj. Good afternoon everyone. So guys, again, I have only started discussing about the homogeneous differential equation. Okay, so again, I'm summarizing it for you, the students who have joined late. Okay, so what I'm telling you is that if you find any differential equation of this particular type, dy by dx equal to f of x comma y divided by g of x comma y, and if you can write this, in terms of y by x, then that equation is a homogeneous differential equation. I've taken a very simple example for all to understand. So you see here dy by dx equal to x plus y by x minus y. If you take x as a common in the numerator, x as a common in the denominator, you end up getting this differential equation, right? And if you see the term on the right hand side, everyone, the term on the right hand side is basically in terms of y by x. So what does that mean? Well, this differential equation right here is going to be a homogeneous differential equation. So we can say this is going to be a homogeneous differential equation. So I can tell you guys, this is a very, very easy way to identify whether a differential equation given for you is a homogeneous differential equation or not. Okay. Now, what is the method we need to apply, okay, to solve the homogeneous differential equation? Because you see, this type of questions cannot be done using the method of which one? Using the method of variable separable. Because you see here, if you want to write down all the x terms along with the dx and all the y terms along with dy, it's not going to be possible in such type of equations, right? So in this case, we need to basically use a different method for solving homogeneous differential equations, everyone. So what is that method going to be? So sab log yahan pe suno, it's going to be a very interesting method. So whenever you find a homogeneous differential equation, no guys, okay, in that case, all you have to do is take y is equal to vx. What you're going to do in that particular case, everyone, you need to take y is equal to vx. Okay, then find out the dy by dx from this. You're going to get in terms of dv by dx. You apply that modification to that differential equation. After applying the modification, whatever the resulting differential equation you're going to get, no, in that resulting differential equation, guys, definitely you can apply the variable separable method and get the solution. This is how you need to apply the differential equation method. So for example, we were doing this question. Let me apply this method to this question now, guys, and let us see whether I'm able to get the answer or not. Okay, आपको भी पता चल जाएगा ना? So everyone listen to this carefully. Let us say you have dy by dx equal to, so let me take the same example for you. Dy by dx is equal to x plus y divided by x minus y. Okay, now what I told you in this case, I can write this as dy by dx is equal to, let me write the right hand side in terms of y by x. So I'll get dy by dx is equal to 1 plus y by x divided by 1 minus y by x. This is what I'm going to get, everyone. Now, this is a differential equation, a homogeneous differential equation. So what is the method, everyone, for a homogeneous differential equation? You need to take y is equal to vx. Very, very simple. So from here, if you differentiate on both the sides, I'm going to get dy by dx is equal to v plus x into dv by dx. I'm differentiating both the sides with respect to x, everyone, and see, this is what I'm going to get. Now let me apply this modification in the above integral and see, sorry, in the above differential equation and see what am I going to get. So in place of dy by dx, you will get v plus x into dv by dx, simple, and equal to, on the right hand side guys, क्या मिलेगा आपको यहाँ पे? It's going to be 1 plus v, y by x is going to be v, divided by 1 minus v. This is what you're going to get. Okay, and Shalam sir, what is heterogeneous equation? Guys, homogeneous equation heterogeneous nahi hoga. Okay, I mean it's not chemistry where we have a homogeneous mixture and a heterogeneous mixture. Okay, so in mathematics we have homogeneous and non-homogeneous equation. Okay, so a homogeneous is something which is going to satisfy this type of equation. I told you already, if you have f of lambda x comma lambda y, in an equation, if you replace x by lambda x and y by lambda y, you are going to get, if you're going to get this type of equation, let us say lambda raised to n into f of x comma y, guys, इसका मतलब कि ये वाला equation जो भी है ना, this equation is going to be a homogeneous equation. If you're not getting this condition for an equation, if you're not getting this condition, then that is what it is going to be, a non-homogeneous equation. So I can give you an example of non-homogeneous equation also, Shalam. Like for example, x square plus x into y plus y square, okay, plus let us say x plus y plus let us say 1 is equal to 0. This is going to be an example of which one? Non-homogeneous equation. What is this going to be here? This is going to be a non-homogeneous equation, because you see, if you replace x by lambda x, y by lambda y in this equation, you don't get this condition. आप देख सकते हैं clearly आपको ये वाला condition नहीं मिलेगा. So this is a non-homogeneous equation. I hope this point is clear for you. Okay. Anyway, let us get back to the session, everyone. And guys, everyone out there, यार कोई भी doubt. See, for me, there is nothing called as silly doubt. Okay, मतलब कुछ लोग बोलते हैं that this is a very small doubt. ये भी पता नहीं है आपको, ये भी नहीं आता है आपको. Like in fact, I have faced the same thing when I was in 11th and 12th. I used to have such, small doubts, and whenever I used to ask to anyone, they used to tell me that, यार ये भी नहीं पता है क्या? But see, guys, you need to understand that जो भी question है पूछ लो, small question, big question, it doesn't matter. When you ask a question, you'll know the concept, you'll know the right concept, and from that you are going to learn the concept, learn the subject in a right way. Okay, so I'm telling you, जो भी doubt है, let me know in the chat box, everyone. Small doubts are also welcomed. Okay, I'll definitely address all your doubts. I'm going to clarify all your doubts. Okay, so that at the end of the session आपको कोई भी कॉन्सेप्ट में कोई भी मतलब डाउट नहीं रहना चाहिए. यू हैव टू बी वेरी क्लियर विद द एंटायर कॉन्सेप्ट. दैट इज द मेन मोटो ऑफ दिस एंटायर सेशंस, एवरीवन. Okay, so yeah, I think again I'm telling you guys, you have any doubt, let me know in the comment section or in the chat box. I'll definitely reply to everyone. Chalo, so let me get back to the question then. So dy by dx, so I got this one right. Why v plus x into dv by dx is going to be equal to 1 plus v by 1 minus v. So what you can do here is that you can take it in this way. No, x into dv by dx is equal to 1 plus v divided by 1 minus v minus v. And if you take the LCM, this is what you are going to get. I'll get 1 plus v minus v plus v square divided by 1 minus v, everyone. Okay, so this v and v is getting cancelled. So can you guys tell me what is the resulting equation you're going to get? X into dv by dx is equal to 1 plus v square divided by 1 minus v. So here, can you see this differential equation? Can we apply the variable separable method in this differential equation? Hell yeah, we can definitely apply the variable separable method to this differential equation. You see, I can write this as 1 minus v divided by 1 plus v square into dv is equal to dx divided by x. Guys, see, I have written all the v terms along with dv, all the x terms along with dx. So what is this going to be? Well, this is going to be a variable separable method. So अभी आप क्या करेंगे? All you need to do is integrate on both the sides. From here you have to solve those integrals. From that you are going to get the solution. And guys, in the final answer which you get, put v is equal to y by x. That is going to give you the final solution. So this is how you need to tackle the questions of homogeneous differential equation. So first, again I'm telling you, जो भी homogeneous differential equation question आ गया है ना, so what you need to do in that case, you have to follow three simple steps, only three simple steps, everyone. The first step, identifying whether the differential equation is a homogeneous differential equation or not. How would you identify that? Very simple. I told you this very simple method. No, if any differential equation, you can write it in this particular format, guys, that is going to be a homogeneous differential equation. The second step, what is going to be the second step, everyone? You take, when you write this in terms of y by x, the differential equation, you take y is equal to vx, you apply the substitution, that is the second step. And after applying the substitution, after applying this modification to the differential equation, whatever the resulting differential equation you are going to get. No, in this case, always remember, we can apply the variable separable method and you can do that question. So I hope this entire concept is clear for all the students out there. Okay, so I hope this is clear for everyone, guys. So good afternoon, Karthik. How are you? How are you, Karthik? How are you? I hope you're fine. So understood this question, understood this entire concept of homogeneous differential equation. Okay, so now let me do one thing, guys. Let me take a question based upon this concept. Let me do one more question. You see this question, everyone. Solve x into dy minus y into dx equal to under root of x square plus y square into dx. What is this going to be? Now everyone, listen to this carefully. In this case, what you can do is that यहाँ पे, so first thing, let me write this entire equation as a homogeneous differential equation form. In the homogeneous differential equation form, let me write this equation. So how do we do that? First, let me divide both the sides by dx. Okay, so I'm going to get x into dy by dx minus y is equal to, guys, this is under root of x square plus y square. Okay, now from here I can write this as x into dy by dx is equal to y plus under root of x square plus y square. Okay, so this is what you're going to get. I can do the modification here. I can write this as dy by dx equal to, guys, on the right hand side I'll get y by x plus, and what is this one going to be? See, this is going to be under root of x square plus y square divided by x, which can also be written as, ये हम स्क्वायर रूट के अंदर ले सकते हैं. So this can be written as x square plus y square divided by x square divided by x square. So this is what you're going to get, everyone. So from here I'm going to get dy by dx is equal to y by x plus under root of, well, this is going to be 1 plus y by x whole square. So guys, you see, I have written the differential equation in the standard form of a homogeneous differential equation. See, I have written the right hand side in terms of y by x. Now all you need to do is what? You take y is equal to v into x, everyone. Okay, so from here, can you tell me what we need to do? Well, let me differentiate on both the sides with respect to x. I'll get dy by dx is equal to v plus x into dv by dx, everyone. Let me apply this modification to this differential equation and see what am I going to get. So dy by dx के place में v plus dv by dx into x, and this is equal to y by x is going to be v plus under root of 1 plus v square. This is what you are going to get, everyone. So guys, v and v is getting cancelled. Okay, now what am I going to get? I'm going to get x into dv by dx is equal to under root of 1 plus v square. Now in this differential equation, can you guys tell me, which method we need to apply to solve this differential equation, everyone? Can we say we need to apply the variable separable method? Yes. So if you apply the variable separable method, I'm going to get dv by under root of 1 plus v square is equal to dx by x. So all you have to do is solve this integral, matlab you have to solve these two integrals to get the solution, everyone. So the rest of the part I'm going to leave it for you. आप लोग कर लेना. It's a very simple integral. dv by under root of 1 plus v square, a standard integral. Integration dx by x, another standard integral. So apply the formula and get the solution. So I hope this question is clear for all the students out there. Okay, Karthik, question sets are available in the PDF. Yes, in the PDF you can find all these notes, everyone. Whatever I'm writing down, you can find everything in the PDF. Okay, so don't worry. The PDF आपको मिल जाएगा in the description. After the class, you can download it from the description, everyone. Okay, so understood this question? So this question is a homogeneous differential equation question. जिसमें हमने क्या किया है? Well, first we have written in the standard form. So I told you three steps, three simple steps. First, जो भी differential equation दिया है, if you want to apply the homogeneous differential equation method, write it in the standard form. That is, write the right hand side in terms of y by x. Then the second step, take y is equal to vx. And after applying this modification, you end up getting a differential equation for which we can apply the variable separable method. You apply the variable separable method, from that you are going to get the solution. So I hope this question here is clear for all the students out there. Okay, so guys, this is about the concept of which one? The concept of homogeneous differential equation. Okay, and see, sometimes for a homogeneous differential equation, you also have to use x is equal to y into y. Sometimes, let us say, sometimes जो भी question है ना, let me write down that note for you so that you will not get confused if you see that type of questions. Okay, so let me write down a note. Sometimes what happens is that जो भी differential equation दिया है, okay, let us say that differential equation is in this way, guys. dx by dy is equal to f of x comma y divided by g of x comma y, and if you do the simplification, you ended up getting the right hand side in terms of x by y. In that case, everyone listen to this. Okay, in such type of differential equations, you go with x is equal to v into y. You go with this particular substitution. Definitely, after applying the substitution, whatever differential equation you are going to get, in that differential equation, you can apply the concept of variable separable method. Okay, so now let me go to another important method of today's session. And guys, that is going to be which one? Well, that is going to be the linear differential equation method. Yeah, I told you already in the starting of the session. Everyone out there, listen to this. From this chapter, 50 to 60% of the questions are based on this concept, which is linear differential equation. Okay, so you can understand how important this chapter is, right? So that's what I'm telling you. You concentrate on this. I'll teach you in a very clear way, in a very crystal clear way. Let us discuss about linear differential equation method. Okay, so now everyone, first identifying कौन सा इक्वेशन, कौन सा डिफरेंशियल इक्वेशन लीनियर डिफरेंशियल इक्वेशन होगा. You need to identify that first. Okay, so how can we do that, everyone? Very simple. If you see any linear differential equation of this particular type, देखो यार यहाँ पे अगर आपको कोई भी linear differential equation दिखेगा of this particular type, जहाँ पे this p and q are going, I'm sorry, are going to be functions of x, or it can also be constants, not only functions of x. Okay, it can also be constants. Then we can say that this is a linear differential equation in terms of y. Okay, so dy by dx plus p times of y is equal to q, where p and q are going to be functions of x or constants. Then this is going to be a linear differential equation in y, everyone. Okay, so for example, you see here Is this going to be a linear differential equation? Yes, this is definitely going to be a linear differential equation, because you see, in place of p and y, in place of p and q, guys, okay, you can clearly see that in place of p and q, the 7 and 3 are there. I told you p and q can be functions, or they can be functions of x, or they can be constants. So यहाँ पे constants है. So this is definitely going to be a linear differential equation. I can give you another example also, everyone. Let us say dy by dx plus y into cos x plus y into cos x is equal to x. So can I say this is going to be a linear differential equation? Yes, this is also going to be a linear differential equation. So remember everyone, in case of a linear differential equation, remember that p and q are going to be, they have to be only in terms of the functions of x, or they can be constants if you take a linear differential equation in y. Okay, so what's in Telegram? Guys, do join the Telegram group if anyone has still not joined. Okay, in Telegram you're going to get all the updates, related to all these classes. Whenever our classes are going to go live, let us say YouTube में आपको notification नहीं मिला है, okay, you're definitely going to get all those notifications, everyone, okay, in the Telegram once we are live. Okay, and also other than that, you also get exam related notifications also, like let us say JEE main examination ka kuch registration form for March, April, it opened, or let us say any other engineering entrance exam ka form, it is basically, a registration has opened. So we let you know all those updates in that particular group. Okay, so जो भी exam related notifications है, everything you're going to get in that. And also you can interact with us if you have any doubts or any questions. You can do the interaction in that Telegram group. So do join the Telegram group, everyone. In the chat box you can see on the top, you can find that link. Okay, so use that link to join our Telegram channel, everyone. Okay, so chalo everyone, let us get back to the session. So now this is going to be a linear differential equation method. So linear differential equation in y. Sometimes linear differential equation in terms of x is also going to be important for you. Some questions in which linear differential equation in x is also going to be given for you. So in x मतलब क्या होगा कि if you have any linear differential equation in this way, dx by dy, okay, plus p into x is equal to q, where p and q in this case are going to be only the functions of y, or they can be constants, functions of y, or they can be constants. So we can say that this is also going to be a linear differential equation. I can say this is going to be a linear differential equation in x, and this one right here, this is going to be an LDE, linear differential equation in y, everyone. Okay, now you got to know what is a linear differential equation going to be. Now let us understand the method for solving a linear differential equation, everyone. Okay, now there are only simple three methods for you, three steps for you, in fact, to solve any linear differential equation. Okay, so everyone listen to this carefully. Let me just tell you what are those three simple steps going to be through which you can solve any linear differential equation given for you. So let me write it down for you. LDE, linear differential equation method. So what are the three simple steps going to be, everyone, to solve any linear differential equation? Well, the first step for you guys, first identify P and Q क्या होगा. Okay, so to identify, first you need to write down whatever the differential equation is there. Okay, write the differential equation. I'm going to write it down for you here. Okay, write the differential equation in the form of dy by dx plus p times of y is equal to q. Or you can also write in terms of x also. You can write the differential equation in y or in x. It depends upon the question. Okay, let us say if you're getting the differential equation in terms of y, okay, so let us say you need to write it in this particular way. You need to write down, you need to express it in this particular standard form, everyone, which is dy by dx plus p times of y is equal to q. Okay, now after writing it in this form, यहाँ से what you need to do is you need to identify what you need to do. You need to identify what is P and Q going to be. What is P and Q going to be? You need to identify that. Okay, and after identifying what is P and Q going to be, then what you need to do, everyone? Well, the second step is that you need to find out what is the integrating factor. IF का मतलब क्या होगा? Integrating factor. So what is integrating factor going to be? And integrating factor can be found out using a very simple formula, which is e raised to integration p dx, everyone. Okay, so from here you can clearly see that यहाँ से you can find out what is p. Okay, and use that function p here to figure out what is the integrating factor going to be. After getting the integrating factor, the third step is going to be the solution of the above differential equation is going to be given by y into integrating factor is equal to integration q into integrating factor into dx plus c. This is going to be the solution of the above differential equation. So in this solution, you put what is integrating factor, whatever the integrating factor you got, you put that in this equation. Okay, and also in place of q, you put that particular function. Okay, and then you do the simplification. After that, जो भी आपको solution मिलेगा, that solution is going to be the solution of this linear differential equation. So guys, these are the three steps which you need to follow for any linear differential equation question. And let me tell you guys, this is a very simple chapter. Okay, it's a scoring chapter for you. Every year, I'm telling you guys, remember, mark my words, every year from this chapter, one question is asked. Okay, a question तो definitely पूछेगा 4 marks के लिए. Okay, and it's a easy question. The question level of the question is always going to be between easy to moderate from this particular chapter. So if you know the methods, then definitely you will be able to solve that question. No issues with that. Okay, so this is the concept, everyone. This is the method you need to follow to solve any linear differential equation. Let me take a question for you to make you understand, to make it 100% clear how to apply this concept. Okay, so everyone look at the question, guys. आप लोग ये वाले question देखो. Find the integrating factor of dy by dx plus y is equal to cos x. What is going to be the integrating factor in this case? So integrating factor निकालने के लिए first आपको क्या करना पड़ेगा? यहाँ पे you need to identify what is p and what is q going to be. So if you compare the above linear differential equation with the standard form dy by dx plus p into y is equal to q. So guys, what is p going to be? Well, p is going to be 1. And what is q going to be? Well, q is going to be cos x, everyone. I hope it's clear. So what is the integrating factor going to be in this particular case? E raised to integration p dx, right? This is the formula for finding the integrating factor. So e raised to integration p के place में 1 into dx. So I'm going to get e raised to x as an integrating factor. Okay, and if you want to find the solution also in this particular case, everyone, how would we do the solution in this particular case? What solution I'm going to get? It is y into integrating factor, which is e raised to x, is equal to whole integral. Okay, it's going to be which one, guys? क्या होगा आपको यहाँ पे क्या मिलेगा? Q into integrating factor, that is going to be cos x into integrating factor, which is e raised to x into dx. So from here you are going to get the solution. So see, we have applied a very simple method. This method I told you, no, y into integrating factor is equal to integration q into integrating factor into dx. So from here you got the answer, everyone. आप देख सकते हैं यहाँ पे first I got the integrating factor. After getting the integrating factor, to find the solution, y into integrating factor is equal to integration, यहाँ पे integrating factor into q into dx. So now what you have to do is just solve the right hand side. Okay, whatever the integral you're going to get on the right hand side, you solve it, and from that you are going to get the final solution, everyone. Okay, so I hope this question is clear for all the students out there. So now let me go to another question. You see this question, everyone. Solve dy by dx plus y by x equal to log x. So now in this question, let us see which method we can apply to solve this differential equation, everyone. So you guys tell me which method can we apply here. So doesn't it look like a linear differential equation? They could dy by dx plus y into 1 by x is equal to log x. So can you say that this is going to be a linear differential equation in y? You see, dy by dx plus p times of y is equal to q. Right, everyone. So what am I going to get from here? Well, we got to know that it's a linear differential equation. So first point, the first step, I need to find out what is the integrating factor. E raised to integration, well, p is going to be 1 by x into dx. So guys, I'm going to get e raised to integration 1 by x is going to be log x base e, and from here I'm going to get integrating factor to be equal to x. Now once you get the integrating factor, can you guys tell me what would be the solution of the above differential equation? Well, it is going to be y into, it is going to be integrating factor, which is x is equal to whole integral. Okay, it's going to be q into integrating factor. So q is going to be log x into integrating factor x into dx. So we need to solve the right hand side integral, everyone. So how are we going to solve the right hand side integral? Very simple. You can apply the integration by parts. So according to Elate rule, guys, what can we say? Well, according to Elate, this is u and this is going to be v. So if you apply the integration by parts, I'm going to get u into log x into integration v. Integration x is going to be x square by 2 minus of whole integral. Differentiation of log x is 1 by x. Integration of x is going to be x square by 2 into dx, everyone. So यहाँ से you're going to get x into y is equal to x square into log x divided by 2. Okay, minus of यहाँ पे x and x is getting cancelled. I'm going to get 1 by 2. Integration x into dx is going to be x square by 2 plus the c, and from here let me write the final answer, everyone. Y into x is equal to x square into log x divided by 2 minus of x square divided by 4 plus c. This is the solution you are going to get in this case. So I hope this question is clear for all the students out there. So see, it's a very simple question, a direct application of which one? Linear differential equation. Okay, sir, available question sets daily for the practice. Acha, you're asking for the practice, Karthik. Well, we'll do one thing. I'll include few extra questions in the PDF, okay, so that you can practice it. Okay, I hope it's clear for you, Karthik. So don't worry, we'll include some extra questions for you in the PDF, okay, so that you can practice those questions, related and relevant questions of whatever the topic we are covering on that day, on that particular day. We'll include few questions, extra questions, so that you can have a practice on that. Okay, so I hope this question is clear for all the students, everyone. Anyone is having any more doubt in this question? Got it? So linear differential equation method, I hope it's clear for you. Now, let me go to another question also. In fact, another important method which is related to linear differential equation only. Now, sometimes, guys, this is very important, guys. यहाँ पे देखो, guys, sometimes you might find this type of differential equation. Okay, dy by dx plus p times of y is equal to q into y raised to n, where p and q are going to be functions of x or constants. You can find this type of differential equations, everyone. तो यार ये तो linear differential equation नहीं है, right? It's not a linear differential equation. So how are we going to solve this type of linear differential equations, everyone? So remember a very simple method. Divide both the sides by y raised to n. So what am I going to get from that? Well, I'll get y raised to minus n into dy by dx plus p times of, it's going to be y raised to 1 minus n is equal to q. This is what you're going to get. Right, so when you have a differential equation of this particular type, divide both the sides by y raised to n. This is what you're going to get. Now, along with p, you see, along with p, whatever y term you have, you take that is equal to t. What you'll do, you'll take y raised to 1 minus n, you take this is equal to t. तो यहाँ से क्या होगा, when you differentiate on both the sides, I'll get 1 minus n into dy by into y raised to minus n into dy by dx is equal to, you're going to get dt by dx, everyone. Now, if you apply this modification to this term, what am I going to get from here? You see, y raised to minus n into dy by dx is going to become 1 by 1 minus n into dt by dx plus p into this y raised to 1 minus n. Well, we have taken it as t, and this is going to be equal to q. So this can also be written in this way, no guys, dt by dx. Okay, this can be written as plus p into 1 minus n into t, and this is equal to 1 minus n into q. Now, whatever the resulting differential equation we got, no, observe this resulting differential equation, everyone. Guys, this resulting differential equation, I can tell you, this is a linear differential equation, because you see, linear differential equation in t, you see here, dt by dx plus p into 1 minus n. Okay, it's going to be a function of q. Q into 1 minus n is going to be a function of x, sorry. P into 1 minus n is a function of x into t. This is exactly in this particular format. If you see, this is exactly going to be in this particular format, dy by dx plus p into y is equal to q. So यहाँ से you have got the clarity on this particular type of questions, everyone. So whenever you find this type of questions, no, linear differential equations may, this is a concept of linear differential equation only, guys. So in which, if you find a differential equation of this particular type, dy by dx plus p into y is equal to q into y raised to n. Guys, in this case, what you need to do, well, all you have to do is basically divide both the sides by y raised to n first. Okay, and after that, you apply along with p whatever y term you are having, you take that as equal to t, apply that modification. Once you apply that modification, whatever the resulting differential equation you're going to get, no, that resulting differential equation, well, that is going to be a linear differential equation, for which you know the method, you can apply the method, and you are going to get the solution. Okay, so guys, let me do one thing now. Let me take a question for you explaining the same concept. You see this question, everyone. So it's given, solve dy by dx plus x into y is equal to x into y square. Okay, तो यार कैसे करेंगे आप, यहाँ पे देखो यार, यहाँ पे सिंपल सा लॉजिक है. Let me first divide both the sides by y square. Okay, so guys, I'm going to get y raised to minus 2 into dy by dx plus x into y raised to minus 1 is equal to x, everyone. And you see the question is exactly in this format, dy by dx plus p into y is equal to q into y raised to n, where p and q are going to be x, and this y is going to be y square is nothing but y raised to n. It is exactly in the Bernoulli's equation format. This type of equations, we have a special name for that, and we call it as a Bernoulli's equation. Okay, so now what we will do here is that, let me do one thing, guys. Let me take this term, I told you, along with this p, along with this x, यहाँ पे you have y raised to minus 1, you take it as t, and देखो यार क्या मिलेगा आपको यहाँ से. So from here, if you differentiate on both the sides, this is what you're going to get, minus 1 into y raised to minus 2, okay, into dy by dx, yeah, dy by dx is equal to dt by dx. So if you see here, everyone, I can tell you y raised to minus 2 into dy by dx is minus 1 into dt by dx plus x into, well, y raised to minus 1, we can say it is going to be t, and that is equal to x, everyone. So see the resulting differential equation. Let me do the simplification यहाँ पे आप इसको ऐसे भी लिख सकते हैं dt by dx is plus x into t into plus t into minus x is equal to minus x. So guys, the resulting differential equation which you got here, what can we say about this? Well, this is going to be a linear differential equation. Now, what you have to do for this linear differential equation? Well, simply apply the method. So guys, what you have to do? First, let me find out the integrating factor, which is e raised to minus x into dx. So it's going to give you e raised to minus of x integration is x square divided by 2. This is what you're going to get. Okay. So if you want to find out the solution here, the solution is going to be t into integrating factor, which is e raised to minus x square by 2 is equal to integration q, which is minus x into minus or into this one integrating factor e raised to minus x square by 2 into dx. This is what you're going to get. Now we need to solve the right hand side integral. Right hand side integral is very simple, man. If you take minus x square by 2 is equal to t, no, applying the method of substitution, differentiate on both the sides, you see what am I going to get? So I'll get minus x into dx is equal to dt. So if you apply that modification, guys, this is what you're going to get. Minus x into dx is dt, minus x square by 2 we have taken t. So I end up getting e raised to t into dt, and integration e raised to t into dt is e raised to t plus c. So the final solution I'm going to get. So I've taken t as what? Y raised to minus 1. So the final solution I'm going to get is e raised to minus x square by 2 divided by y is equal to e raised to t के प्लेस में it's going to be y, मतलब यहाँ पे 1 by y plus c. This is the solution you are going to get for this differential equation, everyone. So I hope this is clear for everyone out there. Anyone is having any more doubt in this question? Got it? So first, what we have done, whatever the differential equation we had, it is going to be a Bernoulli's equation. Okay. So for that, we know the method. So we applied that method. We got a linear differential equation. So after getting the linear differential equation, we applied the method of linear differential equation. We got the integrating factor, which is e raised to minus x square by 2. Then I got the solution, which is t into e raised to minus x square by 2 is equal to integration q into this integrating factor. So from here, I got the solution, everyone. So I hope this question is clear for all the students out there. Okay. Hello, Ashwin. Good afternoon. So I hope this is clear, everyone. चलो, so now let me do another question for you. आप लोग ये वाले question भी देखो. यार same method है. Again, this question also you have to identify. You know, whenever the differential equation is given for you, आपको पहला identify करना है. In this question, which method can I apply? आपके पास चार ही method है. Okay, variable separable, homogeneous equation method, linear differential equation method, and the Bernoulli's equation, right? So you have to first identify this differential equation exactly fits into which form, and accordingly you have to do the simplification. So how should we do this question, everyone? Simple. You see here dy by dx. Okay, let me write down dy by dx plus 2 plus x into, or I can write down plus 2x into tan y divided by secant square y, okay, is equal to x cube divided by or else we can do it in this way. You see this question, everyone, यहाँ पे आप इसको ऐसे कर सकते हैं secant square y into dy by dx, okay, plus what is this given for you? Plus 2x into tan y, or I can write it in this way. Can we write this as equal to x cube minus of 2x into tan y? You can write it in this way. Okay, now from here you see what am I going to get, everyone? So I'll get dy by dx as x cube divided by secant square y, okay, secant square y, and this is going to be minus of 2x into tan y divided by secant square y. This is what you're going to get. ओके नाउ यहाँ पे आप लोग क्या कर सकते हैं, एक्चुअली गाइस यहाँ पे थोड़ा सा गलती हो गया। दिस शुड बी इन टर्म्स ऑफ दिस वन, ये dy by dx नहीं होगा यहाँ पे, दिस शुड बी लेट अस से dx by dy। ओके सो लेट मी नॉट टेक dy by dx यहाँ पे, दिस शुड बी dx by dy everyone। यहाँ पे let me do that modification। so यहाँ पे आप ले लो dx by dy so that you get the right answer। so let me just take this as dx by dy। okay so dx divided by, so यहाँ पे this is dx, this is going to be dy, yeah this is also going to be dx divided by dy everyone। okay now you see here, now इसको आप ऐसे लिख सकते हैं ना, dx by dy, okay dx divided by dy, okay and this is going to be plus x into okay what is this going to be, 2 into tan y divided by secant square y everyone, and that is equal to 1 by secant square y, 1 by secant square y into, it's going to be x cube. Now when you see this question, no, when you see this differential equation, guys, this is exactly in this format. You see dx by dy plus x into, it's going to be p is equal to q into x raised to n. It's going to be exactly in this format. So what is this type of differential equation going to indicate? Well, it is a Bernoulli's differential equation. Guys, Bernoulli's differential equation, like if you write it in terms of y, it looks like this, dy by dx plus p times of y is equal to q into y raised to n, where p are going to be the functions of x. If you write the Bernoulli's equation in terms of y, this is how it's going to look like. If you write the Bernoulli's equation in terms of x, it is dx by dy, okay, plus it's going to be p into x is equal to q into x raised to n everyone, jahan pe p and q have to be only the functions of y, and see exactly we got the same thing. Okay, so I hope it's clear for you. So you identified that this is going to be a Bernoulli's equation. So what are you going to do in this case everyone? Very simple. First divide both the sides by x cube. I'll get 1 by x cube into dx by dy, okay, plus यार ये होगा x by x cube, that is 1 by x square into 2 tan y divided by secant square y, and that is equal to 1 by secant square y. So the method remains the same. I told you the method already, what method you need to apply for a Bernoulli's equation, you have to apply the same method everyone. So what am I going to get in this particular case? So you can take 1 by x square is equal to t, okay, and if you do the simplification guys, I'm going to get minus 2 by x cube into dx, that is going to be basically dt. So dx by x cube, yahan pe if you can do, like if you're differentiating both the sides, let us say with respect to y, okay, I'm going to get minus of 2 by x cube into dx by dy is equal to, yahan pe it's going to become dt by dy. Okay everyone, so I can say d1 by x cube into dx by dy is going to be minus 1 by 2 dt by dy. If you do the modification, I'm going to get minus 1 by 2 dt by dy, okay, plus what is 1 by x square going to be, t into this particular function, let me take that to be p is equal to q, and from here I'm going to get this as dt by dy, okay, plus t into minus 2p is equal to, and what is this one going to be everyone, it is minus 2q, and yahan pe guys you tell me what is this differential equation going to be? Well, this is going to be a linear differential equation. So apply the method and try to get the solution. So I hope this question is clear for all the students out there. Okay, so first thing, yaar ye wale question mein first we have identified the differential equation is simply nothing but a Bernoulli's equation. We have applied the method of Bernoulli's equation, and after that you have taken the substitution, 1 by x square is equal to t, differentiating both the sides with respect to y, I got minus of 2 by x cube dx by dy as dt by dy. Applying this modification, you see the resulting differential equation we got. The resulting differential equation equation is going to be a linear differential equation, and from that we got the answer. We are going to get the answer anyway. You have to just solve this equation. You already know how to solve a linear differential equation. Apply that method to this particular differential equation, you are going to get the solution. So I hope that this question is clear for all the students out there. So guys, now what we will do is that let me do a previous year question for you everyone. You see this question everyone, it's a JEE Main 2020 question, okay, on the concept, based on the concept of what we have discussed today, the variable separable method and the homogeneous differential equation method and the linear differential equation method. Based on those two methods, I have taken few questions for you. Okay, you see this question everyone. It's a JEE Main 2020 question. Let us see how do we solve this question. And before that, guys, to this particular point, if you have understood all the topics, क्या करेंगे आप लोग यहाँ पे? Guys, do like the video so that this video will reach, the maximum number of students and which are going to be helpful for them also. Okay, so chalo guys, let us start doing this question now. Let y is equal to y of x be the solution of the differential equation x into y dash minus y is equal to, this is given for you, is asking you to find the value of y double dash of pi by 2 plus y of pi by 2 if y of pi is equal to pi is given for you. So let me do one thing. Let me take this question to another slide and let us see what will be the answer in this case everyone. So guys, यहाँ पे सब लोग देखो यहाँ पे, how do we do this question? A very simple question. So first thing, x into y dash is dy by dx my is equal to y plus x square. Or we'll do one thing. Let me take minus y only. Minus y is equal to x square into x into cos x plus sin x. Okay, fine. So this is the differential equation given for you. Now what we can do here, let me divide both the sides by x. What am I going to get? I'll get dy by dx plus y into minus 1 by x everyone equal to x square by x is going to be x into x cos x plus sin x. This is what I'm going to get everyone. Okay, now from here, this is basically a linear differential equation. You see, dy by dx plus y into p is equal to q. It's a linear differential equation. So apply the concept of linear differential equation. So integrating factor क्या होगा? E raised to integration p dx minus 1 by x into dx equal to e raised to, guys, integration minus 1 by x into dx क्या होगा? It's minus log x base e, okay, which can also be written as e raised to log of x raised to minus 1 to the base e, and the result I'm going to get is x raised to minus 1. If you apply the logarithmic property, you end up getting 1 by x in this case everyone. So I can tell you the solution जो भी मिलेगा, it is y into integrating factor y into 1 by x is equal to whole integral, it's 1 by x integrating factor into x into x cos x plus sin x into dx. So guys, this is what you are going to get everyone. Okay, now let me do the simplification. X and x is getting cancelled. We have to solve the right hand side integral. I'll get y by x is equal to integration x into cos x plus integration sin x into dx. So guys, this is what I'm going to get in this case. Okay, now let me do this one everyone. Y by x is equal to, for x into cos x we need to apply the integration by parts, where we can say according to Elate, x is going to be u, cos x is going to be v. So u into integration v, I'm going to get x into integration cos x is going to be sin x everyone, minus whole integral u dash, differentiation of x is going to be what? It is going to be 1. Okay, and again integration of cos x, it is going to be sin x, it is simply going to be sin x, okay, into dx plus this is going to be integration sin x into dx everyone. So you can clearly see that these two terms are getting cancelled. I'm getting y is equal to, what am I going to get here everyone? Y is equal to x square into sin x, और यहाँ पे plus c into x. So this is what you are going to get. Okay, now to find the value of c, what you can do here, we have this condition that y of pi is going to be equal to pi. So at x equal to pi, you see what is the value of y you're going to get. At x equal to pi, y is given as pi. So if you put that in the above equation, what am I going to get here, everyone? Pi is equal to pi square into sine pi is 0. So I'm going to get 0 plus c into pi. So pi is equal to c into pi. So from here, the value of c is going to be 1. So I'm going to get the equation as y is equal to x square into sine x plus x. So this is what y is going to be. We need to figure out what is y of pi by 2 plus y double dash of pi by 2 value. Right, everyone? So we already got what is pi going to be, right? What is y going to be, which is going to be x square into sine x plus x, everyone. This is going to be y. If you differentiate on both the sides, I'll get y dash, which is 2x into sine x, okay, plus x square into cos x plus 1. And if you find y double dash now, guys, it's going to be 2 sine x plus 2x into differentiation of sine x is going to be cos x, and x square cos x differentiation, it's going to be 2x into cos x minus of x square into sine x. This is what you are going to get. Okay, now all we need to do is find the value of y and y double dash at pi by 2. So y of pi by 2 value is going to be how much? It's going to be pi square by 2 plus pi by 2 yahan pe. Okay, and y double dash of pi by 2, what is that value going to be? It's going to be 2 plus, I think it's going to be 2 minus, yahan pe it's going to be pi square by 2. So when you add this to everyone, when you're going to add y of pi by 2 plus y double dash of pi by 2, you see what solution you're going to get. Guys, you're going to get pi by 2, pi square by 2, pi square by 2 to cancel hoga. The answer you're going to get in this case is 2 plus pi by 2. And if you see the options, everyone, well, the option B is going to be the right answer. So understood this question, everyone? देखो यार, जेई मेन 2020 में पूछा था. 2020 ही नहीं, आप 2021 पेपर ले लो, 2019 पेपर ले लो, कोई भी शिफ्ट ले लो, उसमें लीनियर डिफरेंशियल इक्वेशन का क्वेश्चन पक्का है. And out of all those questions, 60% questions, as I told you, linear differential equation से ही होगा. ओके, एंड यू सी द सेम थिंग यहाँ पे. ये वाला क्वेश्चन तो डायरेक्टली लीनियर डिफरेंशियल इक्वेशन के मेथड पे ही होगा था पूरा. एंड सी वी गॉट द सॉल्यूशन. सो आई होप दिस क्वेश्चन इज क्लियर. वेरी वेरी सिंपल क्वेश्चन गाइस. मतलब ये तो इजी लेवल का क्वेश्चन है, इजी 4 मार्क्स वाला क्वेश्चन है आपके लिए, जहां पे ऑल यू हैव टू डू is apply the linear differential equation method. So for that, you need to get the integrating factor, the solution. After getting the solution, find y double dash and then find the value of y and y double dash at pi by 2. यार वहां से आपको solution मिल जाएगा. Okay, so I hope this question is clear for all the students. Let me do another question also. ये 2019 में पूछा था guys, JEE में 2019. I just show you how to do this question. In fact, you can also try this question from your side. Okay, so let me just show you how do we what type of method we need to apply for this question, everyone. So see here, everyone, यहाँ पे. So in this question, what is given for you? Y square minus x cube into dx is equal to x into y into dy. Okay, so let this can be written as dy by dx is equal to y square by x into y, right, minus of x cube divided by x into y. You can write it, you can basically write it in this way. So from here I'm going to get dy by dx is equal to, guys, this is y by x minus of, this is x square by y, everyone. Okay, now इसको आप ऐसा लिख सकते हैं ना, dy by dx minus of, in fact, plus y into minus 1 by x, everyone, equal to, this is going to be minus x square into y raised to minus 1. Can you write the above differential equation in this way? I have taken y by x to the left hand side. I got y into minus 1 by x equal to, this is minus x square into 1 by y raised to minus 1. If you observe this differential equation now guys, can you tell me this looks like which format? ये कौन से type of differential equation जैसे दिख रहा है यहाँ पे? Can I say this exactly looks like this? dy by dx plus p times of y is equal to q into y raised to n everyone. Can you see the differential equation exactly looks like this? जिसमें आप देख सकते हैं p is minus 1 by x, q is going to be minus x square, y raised to n is y raised to minus 1. तो यार ये एक Bernoulli's equation है. So we know the method for Bernoulli's equation everyone. So apply that method. So according to that method, what are you going to get in this case? Very simple. आप क्या करेंगे? ये जो भी y raised to minus 1 है ना, तो पहला तो आप divide करेंगे on दोनों side. So I'm going to get y into dy by dx. Okay, and this is going to be y square into minus 1 by x is equal to minus x square everyone. You take y square is equal to t, differentiate on both the sides. So 2y dy by dx, that is going to be equivalent to, yeah, dt by dx. So y into dy by dx, I can say it is 1 by 2 dt by dx plus, in place of y square, it is t into minus 1 by x is equal to minus x square everyone. So from here I'm going to get dt by dx plus t into minus of 2 by x is equal to minus 2x square, and you see we got a linear differential equation. So all you have to do right now is solve this linear differential equation and see what solution you're going to get. So guys, I'll leave that part for you. Okay, and also let me tell you आपको क्या answer मिलना चाहिए. You need to get option A as the right answer everyone. So whatever the simplification part is there, just applying that linear differential equation method, you do that and you see what solution you're going to get. As I told you, you have to get option A as a right answer. Okay, so I hope this question is also clear for you. So again, you can see in this question also the concept of Bernoulli's equation, linear differential equation is being used. Okay, so guys, that is about the today's session everyone. So understood all the topics which we have discussed today. All the students out there, समझ में आ गया सभी को आज कि क्या टॉपिक्स हमने डिस्कस किया है. So today we have covered the homogeneous differential equation. I told you what is homogeneous equation going to be, what is going to be a homogeneous differential equation, the method to solve a homogeneous differential equation, and also we have discussed about this concept of linear differential equation, the method to solve linear differential equation, and also the Bernoulli's equation guys, and how do we basically simplify a Bernoulli's equation to a linear differential equation. So guys, thank you so much everyone. Thanks Karthik, thank you everyone out there. So guys, it was a wonderful session. So do like the video and let me know in the comment section guys what you have enjoyed most in this particular session today. And guys, if you are still not a part of Telegram channel, do join the Telegram channel. आपको QR code दिख रहा है screen पे. Link is also available on the screen, right? So through that you can join the Telegram group where you get the notifications, instant updates, and exam related notifications in that group. Okay, and guys, one more important thing. If you have enjoyed the today's session, if you have understood all the topics, क्या करना है आपको यार, like करो वीडियो को, share करो it to your friends. You have your friends, right? I mean, it's not like you're preparing on your own. आपका friends भी होगा same class में, and they are also preparing for the JEE examination. So share this video, tell them to join from the next lecture so that they can also learn along with you. राइट आप लोग मतलब साथ में आ जाओ, साथ में आप पूरा गैंग लेके आ जाओ चैट सेक्शन में. वट एवर डाउट्स यू हैव, you can ask me in the chat box. We'll discuss, we'll have a constructive discussion, and guys at the end of the session आपका सारे doubts clear होगा, and you will also have मतलब आपका doubts भी clear होगा, concept भी आपका पूरा clear हो जाएगा वहाँ पे. Okay, and guys, if you have not subscribed to the channel guys, do subscribe the channel. Okay, do subscribe the channel so that you get all the updates and जो भी notifications ये आपको सारे मिल जाएगा instantly. Okay, चलो then, thank you so much everyone. Take care guys, let us meet in the next session. तो यार next session होगा 6 p.m. को. The next session is going to be at 6 p.m. where I'm going to talk about some applications of differential equation, and यार we'll do many questions of differential equation पूरे chapter के ऊपर. On the entire chapter of differential equation, let us do few questions everyone. I'll take some previous year question 2021, 2020, 2019 के JEE main questions. I'll take it in the next session, and that is going to be at 6 p.m. today. So definitely guys do join the session at the 6 p.m. Okay, so thank you so much everyone. Guys, take care everyone. Chalo guys, then मिलेंगे 6 p.m. के session पे. Okay, so bye everyone, take care guys, bye bye.